Good afternoon to everyone. It's 1:30, time to start. I would like to welcome you most cordially to our webinar introducing new Eurovent recommendation for 23 concerning selection of an ISO 16890 rated filter in general ventilation systems. Our webinar will take approximately 40 minutes, of course, depending on the number of question you will ask, but I'm pretty sure it's worth to spend this time with us because we'll be discussing a very hot and important topic to all professionals dealing with ventilation and filtration issues. Let me introduce myself. My name is Igor Sikończyk, and I'm a technical and regulatory affairs manager at the Eurovent Association. Today with me there are two guest speakers from the Eurovent product group Air Filters, so the group whose members developed the recommendation, the chairman, Mr. Jan Andersson from Camfil, and the vice chairman, Dr. Thomas Caesar from Freudenberg Filtration Technologies. Today's webinar agenda is following. First, I would like to brief you on Eurovent Association. Very shortly indeed, as I guess some of you might be not fully aware how Eurovent is structured and what is the exact scope of our activities. Next, just two sentences about new AN ISO 16890 standard, which stands behind the reason why the recommendation was developed. Then we'll try to consider what implication on the market and introduction of a new standard resulted in. Thereafter, we'll move on to the main point where I will elaborate in depth on the recommendation content. And finally, our guest speakers will answer your, I hope, numerous questions. So let's start with association. Eurovent is the Europe's industry association of manufacturers supplying ventilation, air conditioning, and refrigeration equipment. We have members in over 20 countries, and we create a very strong network of leading national industry associations. All manufacturers affiliated in national association are also Eurovent members, and their number amounts to over 1,000 companies. How we look in numbers, over 1,000 participants, and these are mainly small and medium-sized manufacturers from Europe, Middle East, and North Africa region. They employed around 150,000 people and generate a combined annual turnover of more than 30 billion euro. This means that our voice in a discussion with policymakers is very loud and recognized. Our core activities can be sorted into three main fields. The first one is advocacy. We actively participate in the development and revision process of the legislation, both on European and national level, where we represent best interests of our members. The second field is marketing. We promote the European industry and its modern technologies on the market outside Europe. And in this way, we contribute to a level playing field for all manufacturers and to eliminating unfair trade barriers. And the last one is technical. For one thing, we follow development of European and international standardization and keep our members updated what is going on. But in the fields where standards are not really available, we develop so-called codes of good practice, Eurovent recommendation, which often became a base for future standards. And the recommendation we will be talking about today is a very good example of such an activity. I would say that particularly Air Filters product group is very active in this field. So I mean field of publishing recommendation. Here are some examples from past, going back to 1980s. Recommendation 4.5 so method of testing air filters used in ventilation system. And this was in fact first European standard defining, I guess still well remembered by some of you, classes EU1 to EU9. Back in the 90s, recommendation on standard filter dimensions, which are now commonly used, and some latest developments, so recommendation on determination of energy used by filters, also addressing energy efficiency of filters, or recommendation on testing of residential air filters performance. And moving slowly to the end of this first point, very shortly how the Eurovent world is structured. We have three units. The first one is association, which activities I have already introduced on the previous slide. The second one is Eurovent certification, acting completely independently from the association. And this is a major European certification body operating over 40 certification programs, including one program for filters. And the third unit is Eurovent Market Intelligence. This is an European Statistic Office providing key market data since 1994. Okay, so knowing already nearly everything about Eurovent, we can move on to the next point concerning an ISO standard. This standard was published already 1 year ago in December 2016. So we don't want to go into details of this standard, but just to recall most important issues important from ventilation system design point of view. So this standard introduced a new, more realistic classification of air filters based on three ranges of particle sizes: PM1, PM2.5, and PM10. And this in turn provides completely new opportunities for designing indoor air quality depending on outdoor air contamination. But what we must remember, this is still a testing standard which does not provide recommendation on correct application of respective filter classes. And moreover, the standard will soon replace EN 779, what means that currently used and well-known filter classes G to F9 will be no valid anymore. And what is most important, the new classification cannot be directly compared or converted to the old one. And this conclusion moves us to the next point. What is happening on the market right now due to introduction of a new classification? And I would say that filter manufacturers are in quite comfortable situation. They have clear testing guidelines, but designers or people dealing with maintenance might feel a bit confused, since no guidelines on European standardization level how to select filters rated according to the new standards are available for now. Even the major European related standard providing requirements for ventilation system, including guidelines on filter selection, still refers to previous EN 779, although it was in fact published later than an ISO standard. So as you can see, the situation is a bit tricky, and looks like the development of standards concerning system design is a bit delayed. So what was the Eurovent answer to the situation? Recommendation 423. This document was prepared in joint effort by experts of product group air filters based on very deep technical knowledge and experience. The main defined goals were the following. For one thing, to fill this existing standardization gap and to provide comprehensive guidelines on selection of filters rated according to the new standard, but also, as a second point, to possibly constitute a contribution to a necessary revision of already mentioned standard EN 16798 part 3. And in turn, the basic assumption was following: to make this document as an easy and simple to use tool addressed to all professionals dealing with ventilation system, particularly consultants, facility managers, but also manufacturers of equipment, including air filters. And the second very important assumption was to base the recommendation on particle matter concentration thresholds recommended by World Health Organization. And it was to make the recommendation consistent on international level. All this resulted in the following content of a recommendation. First chapter is dedicated to importance of filtration, where we refer to some facts and figures highlighting why applying correct filtration is so crucial in respect of health, but also in terms, in a way, of global economy. In the second chapter, we compare previous and current filters classification. In next chapter, the most important one, we provide a recommendation how to select filters efficiency for various applications. And in two last chapters, we propose a simplified method for estimation of multi-stage filtration system efficiency and focus on importance of energy efficiency of filters. Let's take a look at contents of respective chapters. In a part concerning importance of filtration, we highlight that particle matters is a pollutant which affects the greatest part of the population comparing to other pollutants. And we also point out major serious diseases associated with exposure to high particle matter concentration in the air. And these diseases are allergies and asthma, lung cancer, cardiovascular diseases, and chronic obstructive lung disease. We show also how particle matters of respective size penetrate human respiratory duct. And the general rule here is that the smaller the particle, the more dangerous it is. While particles with diameter above 10 microns can be retained in the nose, which is a sort of natural filters, particles with a diameter of less 1 micrometer can even enter bloodstream and result in cancer. So that's why when designing system for rooms of high health and hygienic requirements, we must consider EPM1 fractional efficiency, whereas for rooms with standard or low requirements, we can focus on EPM 2.5 or EPM 10 efficiency. But what is also important and sometimes not acknowledged is that effectiveness of filtration can have or has impact on economy through so-called burden of diseases. And here we mean all costs related to health service, medical treatment, or inability to work. This can be measured by DALI, which stands for Disability Adjusted Life Years, a measure which was developed back in 1990, expressing years of life lost due to premature mortality and years of life lost due to time lived in states of less than full health. One estimates that burden of diseases attributable to bad indoor air quality in European Union's amounts approximately to 2 million dailies, and cost of one daily assist even up to 100,000 euro. So as you can see, we are really talking about big money. Expressed by the pie chart on this slide, where you can see that bad air quality accounts for more than 2/3 of total number of dailies. So to sum up, the message from this chapter can be following. We as industry have no real impact on emissions outdoors, so on the pollution of the atmosphere. But what we can do is to provide a real good indoor air quality. What is particularly important when we note that people spend even up to 90% of their time indoors. Moving on to the next chapter, so comparison of EN ISO 16890 and EN 779. As it was already said, these both classification cannot be directly compared and or converted. This comes from differences in definition of a classification, also some differences in testing methods, and relation between these both classification can be determined based on real test data. And we made such an attempt thanks to extensive help from Eurovent certification site. Our colleagues from Paris provided us with a set of aggregated test data, including data of 91 filters delivered by 22 manufacturers. And this led us to draft a comparison table. This comparison table can be found in Annex 1 of a recommendation. It compares the ranges of actual measured average fractional efficiency corresponding to respective EN 779 classes. And as you can see, span of some ranges is quite wide. Therefore, direct matching new and old classes is not really possible. Moving on to the subsequent chapter, the core one, where we provide detailed recommendation how to select correct filter class. The way of selecting which we applied in the recommendation is similar and correspond to the one presented in already mentioned standard EN 16798 part 3. So the correct filtration efficiency is selected depending on the outdoor air quality category, ODA, in a considered location, and required supply quality category, SUP. So in first step of selection, we must determine outdoor category based on annual mean concentration of PM 2.5 and PM 10. The needed data to do this can be found in World Health Organization database, which is available on their webpage. And this database contains data of air pollution monitoring from over 1,600 cities in 91 countries. Alternatively, we can use local monitoring databases. The other categories are defined in a quite simple way in places where World Health Organization guidelines are met, which means that concentration of PM 2.5 is below 10 micrograms per cubic meter, and concentration of PM10 is below 20 micrograms per cubic meter. We have category ODA 1. In locations where guidelines are exceeded not more than 1.5 times, we have ODA 2 category, and respectively ODA 3 category where guidelines are exceeded more than 1.5 times. But knowing only outdoor category is not enough to correctly select filter efficiency, because we must also consider supply category. And this category depends on hygienic requirements of a served room and indoor particle matter. So these indoor emissions originate mainly from cooking activities, combustions, and here we have candles, cigarettes, fireplaces, things like that, or from human activity. Supply categories are defined in a similar way like other categories, but here we have 5 classes and accordingly 5 different multipliers. The problem with subcategories is that normally it's quite difficult, or I would even say very difficult, to estimate indoor PM emissions and to match correctly hygienic requirements. So that's why the recommendation indicates some typical examples of application assigned to respective supply category, both for general ventilation applications and also for industrial ventilation applications. Finally, based on determined sub and other categories, we can easily select the required minimum filtration efficiency using the following table provided in the recommendation. Please note that minimum efficiency for application of high and medium hygienic requirements corresponding to categories sub 1 and sub 2 are defined for EPM1 fractional efficiency. For application with standard hygienic requirements for EPM2 fractional efficiency, and for application with low hygienic requirements for EPM10. The recommended values apply both to efficiency of a single filter or for cumulated efficiency of a multi-stage filtration system. And in case of multi-step filtration, there are 2 additional requirements concerning a class or efficiency of final filter stage. And for categories sub 1 and sub 2, the minimum recommended efficiency is EPM1 50%, and for supplier category sub 3, it's EPM 2.5 50%. But what we must remember, taking care about the indoor environment is of course very important, but we must not forget about protecting internal components of ventilation system, because soiled and clogged coils or recovery heat exchanger mean not only hygienic problems but also decline of energy efficiency, what for sure we want to avoid. So that's why, along with latter criteria, we recommend also minimum efficiency of a first filter stage on the fresh air inlet. And for a system without humidification, this recommended minimum efficiency is EPM10 50%. And for system with humidifier, and particularly we mean here adiabatic humidifiers, EPM 2.5 65%. Based on what was presented, I believe you could agree that the method proposed in the Eurovent recommendation is quite simple and easy, and moreover it makes use of all opportunities for designing indoor air quality arising from a new ISO classification. But this is not all. In addition, we propose one more facilitation of selection when it comes to multi-stage filtration. we proposed a simplified formula for estimating combined filtration efficiency, which results in a minor deviation compared to, let's say, original method of calculating this combined efficiency, which is presented in the ISO 16890 Part 1 standard. And this is because this method is a bit complicated and time-consuming. Provides very high accuracy, but the method which we propose is for sure acceptable for engineering calculation accuracy. So that would be, in fact, all from my side. This was the last slide of the presentation, briefing on the recommendation. Thank you very much.